Hey everyone, so today what we're going to talk about is molar mass, which is a fundamental process that you need to learn, but thankfully it's pretty easy, okay? So what is molar mass? Molar mass tells us the weight per mole of a compound. Okay, it tells us the weight per mole of a compound. What is a mole? Okay, we'll be talking about this a lot more later, but when I say a dozen, you think 12. Okay, when I say mole, you think 6.022 times 10 to the 23rd. Okay, it's a constant number that we have came up with to just represent a bunch of molecules, right? Instead of saying a dozen, or instead of saying 12, you say a dozen. Instead of saying 2,000, you say a ton. Okay, instead of saying 6.022 times 10 to the 23rd molecules, we just say a mole. Okay, so when we look at the periodic table, what we're going to be doing is that we're going to be looking at the number beneath the symbol. So today, what we're going to be doing is we're going to be looking at our periodic table, and we're going to be looking at these numbers underneath our chemical symbol now. So if I look at carbon's molar mass or atomic mass is underneath of it, and it says something like 12.0107, and that is in units grams per mole. Okay, so if I had a mole's worth of carbon atoms, so carbon atom looks something like this. Okay, so that's a carbon atom. If I had 6.022 times 10 to the 23rd of those carbon atoms, it would weigh 12.0107 grams. Okay, so that's what all these numbers underneath with. If I have a mole's worth of those atoms, it's going to weigh a certain amount. So when we get to like heavy atoms like gold, it's got a molar mass of 196.9. So those are really big atoms. If we get a mole's worth of those, it becomes a lot heavier. Okay? So that's molar mass. So I could ask you the molar mass of any element, and you should be able to go underneath and tell me, hey, it's 1.00794 or something along those lines for any element. Okay, but what really you're going to be using it for is compounds. So let's just look at our first compound, NaCl. Okay, and what I'll do is I'll ask you for the molar mass of NaCl. So what I like to do is I just like to divide this compound into its parts, right, into its separate atoms. Well, right now, NaCl is just one sodium atom and one chlorine atom, right? NaCl, one Na, one Cl. And then all we do is, if I want the molar mass of that guy, is I just look up the molar mass of sodium, which is 22.989. You could round up these numbers a little bit. Like hydrogen, I just say is 1. Oxygen, I just say is 16. Ones like chlorine, which are 35.45, I just say that's 35.5. Okay, for sodium, it's 22.98, so I'll just say it's 23. 23 grams per mole. And then I look at chlorine, and as I said previously, it's 35.45, so I'll just say that it's 35.5 grams per mole. Okay, and then at the end, I just add up those numbers. I add them up, becomes something like 58.5 grams per mole, and that's it, guys. That's all it is. It's just seeing how many atoms we are, taking the numbers underneath, adding them up, and getting our molar mass for the whole compound. So if I had a mole's worth of NaCl, it would weigh 58.5 grams per mole. Let's keep going. I got a few more examples here. Let's go ahead and let's do CaF2. If you feel like you can do it on your own, go for it. but here I go. I'm going to go through this guy. So CaF2, okay, this tells me I have 1 calcium, and that 2 there tells me that I have 2 fluorines. Okay, so this compound actually looks like this, with these guys being bonds. Okay, so they're bonded together. I have 1 calcium and 2 fluorines. And all I do is now I'm going to the periodic table and I'm adding up these guys' molar mass. Calcium is 40, close enough to 40. We don't have to be real specific on these. Grams per mole. And fluorines is 19. So I'm going to add a 19 for each of these fluorines. Okay, so 40, 19, and 19. I add them all up, and you should get something like 78 grams per mole. Alright, so that's close enough for me, 78 grams per mole. We're just adding up all those molar masses of all those atoms. Let's do another one. Let's go Mg3 N2. Again, this is telling me now that I have 3 magnesiums and 2 nitrogens. So I got 3 magnesiums, 2 nitrogens. I'm going to add up all their molar masses. Magnesium's 24.3, okay, I can't round that to 24. Okay, I got to keep that one, that's a little too far. So 24.3 for each of these. Nitrogen is 14. I add all those guys up, and I should get something like 100.9. Remember your unit of grams per mole. And that uppercase L, it's lowercase L, okay? That's just the way I write my L's, okay? So when you see this uppercase, that's not how it looks on paper. It's just MOL, lowercase. Let's get just a little bit more confusing, okay? When we start getting more into compounds, you'll start seeing parentheses some. And all that means is that we have these polyatomic ions, which we'll get to later, okay? So this is called calcium hydroxide, okay? And what you see here is that you see this hydroxide, which is a polyatomic ion, in parentheses and a 2 on the outside. That just means I have 2 hydroxides, okay? I just have 1 calcium. There's like a little imaginary 1 there. So I just have a calcium. And then here in parentheses, that tells me that I have 2 hydroxides. So if we were to break up this compound, it would look something like this. Okay, that's calcium hydroxide. Okay, so really we have 2 oxygens. We distribute it through 2 oxygens, and we have 2 hydrogens. Okay. These polyatomic ions, they are just atoms combined, but they're so attracted to each other that they don't separate, and they kind of act like this super element that has merged together that won't separate, and we call them polyatomic ions. You'll see other ones like NO3 and SO4 and PO4, okay? They're all polyatomic ions, and I'll let you know when we're coming up with those. Okay, so here, again, 1 calcium, 2 oxygens, 2 hydrogens. Let's add up everything. Calcium is 40, oxygen 16, and hydrogens have a molar mass of 1. We add all those up, and you should get something around 74 grams per mole. Okay? Let's do another one. Like this. And let's see if you can figure it out on your own. We got AlNO3 3. This is called aluminum nitrate. And now once again, we have a polyatomic ion, NO3, that's a nitrate. It likes to be together, okay? Those N and O's don't separate, but we have 3 of them. So if I were to draw out this compound, it would look something like this. Okay, so it's just an aluminum with 3 nitrates attached. Okay, so we have 1 aluminum. I distribute that 3 through into these parentheses. So I have 3 nitrogens and not 3 oxygens, not 6 oxygens, but 9 oxygens. Okay, we multiply it, right? 3 times 1 is 3, 3 times 3 is 9. We have 9 oxygens. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9. All the way down to the bottom. Aluminum's molar mass, 27. Nitrogens is 14. And oxygens, I don't want to add 16 a bunch in my calculator, but I know I have 9 of them, right? So all I'm going to do is just do 9 oxygens times the molar mass of 16. Okay? I add all those up and I get something like 213 grams per mole. Alright, I'm going to leave you with one more to try on your own. Okay, you can give it a shot. And then that's it. Let's go with a nitrite this time. So let's go with strontium nitrite. Okay? So go ahead and try to figure out the molar mass for this. Alright, so here we go. Again, I'm just adding up all my atoms. I got a SR, 1 strontium, right? There's just a imaginary 1 there. Parentheses, I got this nitrate. That means I have 2 nitrates, so I'm just distributing this through. That means I have 2 N's. And I'm multiplying. Again, remember multiplying. So I got 4 oxygens. Okay, 1 strontium, 2 nitrogens, 4 oxygens. If I were to write out what this would look like, it'd have an NO2 on one side and an NO2 on the other side. 2 NO2s. Get my molar masses. Strontium's molar mass is 87.6. Nitrogens is 14. And oxygens is 16 for all 4 of them. Okay? So I'm looking at this, and I add up all my numbers, and I should get something of 179.6 grams per mole. Okay, so that's molar mass. Not that difficult, but super important, especially when we get into our mole calculations later in this semester, guys. So get some practice and have yourselves a great day.